For problem number 7, there is a table of records of number of weeks for practicing and why the the y reverts to the number of minutes. Find the mean of Kwame's best time each week. Find the standard deviation. Find the Pearson's product moment correlation coefficient in this data. And what type of correlation is suggested by this value. So you will just be using your GDC to encode under spreadsheet the values of x and y, and then statistics to find the mean. So the mean here we'll just copy from the calculator is equal to 16.0923, which is equal to 16.1. So that is the mean score. For part 2, find the standard deviation. Again, you're going to copy. You will use the standard deviation, and that is equal to 1.73226 or equal to 1.73. Again, this is copied from the calculator. And for part 3, find the Pearson. So the Pearson R is equal to negative 0.9007. This suggests strong negative correlation. So the results are illustrated in the following scatter diagram. So also, if you have written it in your, if you have encoded it in your spreadsheet, you can also turn that into graph and it will look like this. B1. Competition occurred every week from week N until week 12. Athletes generally have improved performance competitions. Use the graph to suggest the value of N. So there is a great improvement on week number is. You can see there is a trend here and suddenly there is a drop in the number of minutes. So the less minutes you spent for running, that means your performance has improved. So for number 2, during one of the weeks before the competition began, Kwame was ill. Use a scatter graph to suggest which week was this. So you can see there is already a trend of going down from week 1 to week 5, and suddenly again he picked up minutes. So more minutes was spent for running on this number. So probably he was ill and not able to run well. That's why he spent more minutes in running. So that's week number 6. So for letter C, for the rest of the question, the result from the week Kwame was ill should be excluded. Create piecewise linear model to predict y for the given x. So if we're going to remove this, so you go find the linear function from this point to this point. So when your x is less than 8, linear piecewise. So piecewise there are two graphs here connected. So you try to, with the exclusion of this, find the linear model for all x less than 8, and you will see that you'll have your y you'll have two functions here, two pieces. So you can group them together, although less than 8, and for another graph which is 8 or more. So for less than 8, you will have negative 0. This is point 3 0.361x plus 18.8 18.8 for all. This is 18.8 for all x less than 8. And then after that, you encode this again and then find the linear function that gives you negative 0.086x plus, I think it's 15.1. 15.1. I'm having trouble writing. It's 15.1 for all x greater than or equal to 8. And then part 2, use your model. Compare and contrast in context the coefficient of x in each part of the linear model. In each part of the linear model, you can see that both of them are the coefficients. Both of them are negative. So this one suggests a trend in improving in both parts of the season. Okay, so it's negative. It's just like your slope is negative. So the relation is the more you spend on practice, the less time you are taking. So it's the less time is spent for every practice in the same 500-meter distance. So both are negative. This shows trend in improvement. Use your model to predict the time Kwame would have achieved the week he was ill if he had not been ill. So that's on week 6. So that is carried on by this equation. So we can have for letter D negative 0.361x, which is 6, plus 18.8. So that gives us 16.6 minutes. So using this trend here, if he's not been ill, so probably here would spend 16.6 minutes.